Have you ever wanted to simulate more than two bodies inside of space? Well, unfortunately, that is something that I made, but it's very fortunate because it was actually very fun. Now, going through the journey, it was quite a while, 2 months of coding. I did stop for like a week because I had to actually code for another lab I had for comp, which is a really cool class. But alas, I have the functioning version. So just to show the one of the final products of it, you can see how these planetary bodies can start to be attracted to each other. And I'm going to go through the journey with you, how I got here. So the very first thing I did actually was I had to implement basically a system to actually draw every system down. So you can note here that I have a very limited access, and I do code in most of the things so that I can select. But as of now, it's quite obvious through here, or not obvious, but basically using a limited version of vectorization where I just copy and paste a line over and over, I can generate a constant velocity, and that generates us a graph like this. Note how they have little trails, which was one of the things I was working on, as that'll be quite functional later. And also, in this case, I learned how to save a file onto a computer, which was an additional skill that I learned. Upon version 2, I actually implemented physics, which was very cool. Look at these balls and their parabolic motion. Sadly, there's no cubic because that would require the jerk to exist, which does not. Now, I actually have a written test case here for what you just saw, and now we can have a variable amount of bodies. Now, this is also where I first implemented the six-datum system for storing all the positions, velocity, accelerations, all regarding time of each body, and that's why there are 6 and 10. So two, two for position, two for acceleration, and two for velocity. Now, we also have a kind of vectorization to rapidly go through and actually format each body and calculate their next state given the next time. And we are saving all this with an artist position. Now, in our third concept, we actually could not get this one to work precisely yet, but there is the splitting of into a subplot to access more functions and also a variable function length that can be expanded. One thing we can note, however, was that due to us using a pillow artist, it saved every artist in every frame, which was a difficulty we had to overcome by rewriting the code to instead use the Func animation script, which is much more efficient. We also finally got the trails working, and we can see kind of through this broken version of V3 that at the very least a trail is made between these two. However, the critical issue was that the bodies, due to Newton's law of gravitation, as seen in this formula, the acceleration due to gravity is inversely squared to the distance between them, which means that on very small distances, acceleration can explode, and that's what happens. On our fourth variation, this is where we finally build a bit more UI, and we were able to run through more test cases and we are now able to store labels, and also we fixed it by capping the distance that two objects can accelerate each other at. We have everything factored through, and we added the option for including the labels or not, and we also increased and added the units for addition, and now we can see that each object can actually attract onto each other and they don't immediately explode through endless repetition.